It is my pleasure to review the pathogenesis of AMD and the pathways to CNV and GA and to identify potential sites of therapeutical intervention. AMD is an aging process that has environmental factors, genetic polymorphisms that will cause a decline in the ability to respond to the cumulative impact of the high blood flow, high metabolism vision, reactive oxidative species from phagocytosis, photooxidative stress, sunlight, causing a photooxidative stress and RPA damage. Another unquestionable fact are the drusen formation and Brooks lipid deposition and thickening, as well as neovascularization and eventually fibrosis, and RPE cell death, photoreceptor cell death, and atrophy. One of the most important environmental factors is diet that will impact in the body mass index, as well having a fat-rich diet, and also in the microbiome. And on the side of the genetic polymorphisms, complement pathway, lipid pathway, and extracellular metrics and ARMS 2 will have a very significant impact. Both diet and lipid pathway genetic polymorphism abnormalities will cause an abnormal mitochondrial RNA, abnormal lipid and cholesterol RPF flux, contributing to abnormal lipid peroxidation, as well as an impairment on the RPE phagocytic capacity and causing build-up visual cycle waste, lipofuscin, and A2E. On the other hand, the abnormal haplotypes on the complement pathway will cause an exaggerated innate immunity response. The other major pillar of AMD, abnormal inflammation and lipid peroxidation. Abnormal lipids from lipid peroxidation, complement overactivation, and the buildup in the visual cycle waste will cause an LRP3 inflammasome activation. Complement overactivation will also contribute to the lipid deposition in the and drusen formation. Increased body mass index and microbiome will also impact in an exaggerated innate immunity response. Also, genetic polymorphisms that will affect mitochondrial oxidative stress will cause primary RP mitochondrial damage that will produce loss of dicer1, accumulation of oleoRNA, and also contributing to inflammasome activation, as well as also contributing in the RP phagocytic impairment. The inflammasome activation will induce cytokines and BGF with the reparative angiogenic response of neovascularization, also inducing peripheral immune cell infiltration that will also impact in this reparative angiogenic response, and also RP cell death directly. Some authors propose that primary choriocapillaris dropout might be also a cause of RP damage in AMD. We don't want to forget, as environmental factors, that smoking is also a major contributing factor impacting in the photooxidative stress. As in other deposit diseases, no matter what is the origin of the deposits, they may become toxic by themselves, causing inflammation and cell death in the vicinity cells when this material is spilled outside of the cell, what we called drusen ooze. These toxic drusen extracts may also activate inflammasomes, causing a vicious cycle of inflammation, toxicity, cell death, cytokines, further release of extracts, and so on. These toxic drusen debris might also cause microglia activation and macrophage-like RP activation that further would contribute to cytokine and BGF production. As already said, inflammasome activation might cause necroptosis and pyroptosis and cell death by itself. further releasing toxic drusen debris that would cause cell-to-cell progression of death. And finally, ARMS2, an extracellular matrix pathway abnormal polymorphisms may cause abnormal extracellular matrix, contributing to Brooks lipid deposition and thickening, also inducing cytokines and BGF production, as well as contributing to the photooxidative stress. Nowadays, current investigational approaches are targeting complement pathway with several drugs targeting complement different levels, also mitochondrial oxidative stress, lipid pathway, and microbiome, and also targeting directly to drusen while avoiding its formation or trying to get rid of them to avoid the vicious cycle of inflammation and toxicity that they may cause. In summary, AMD is a very complex multifactorial disease with several pathological pathways involved that in addition result in different phenotypes with different prognostic and different progression. And therefore, therapeutic approach is likely to be a combination of strategies targeting different levels and sites of this complex pathogenetic diagram. Thank you very much.